How you all are? Hope good. So thank you so much for joining us today's session. Let us start with the Sine Rule for today. What is Sine Rule? That we will understand. Okay. What is Sine Rule? We will see the derivation, my dear friends, first. How that rule is arrived and what is the formula that is going to be derived for a triangle. Let us say any triangle, maybe any triangle whose sides are A, B, and C. Right? The sides of the triangle are A. Let us say this is A. If this is A, the vertex is A, right? Then here it will be B and here it will be C. Then the side opposite to angle B will be B. Side opposite to angle A will be a small a. Side opposite to angle C will be a small c, right? So A, B, C are the angles. A, B, C are the angles, and a small b, a small c are the sides corresponding to that triangle. Okay. So my dear friends, you know that from any three distinct points a circle can pass on, right? And if we just connect, if this is the center of the circle, okay, and let us join these three the vertex B and C with the center of the circle, right? Like this, like this, right? When you join it, then if the radius of the circle is represented by R, right, then this will also be equal to R, right? So into this case, what will happen, if the angle over here is A, the angle subtended by the arc BC on the remaining half of the circle is A. If this is angle A, then definitely if this is center O, angle subtended by the arc BC at center O will be how much? Tell me. Definitely, if this is A, then this angle will be 2A. This will be equal to 2 times A, because angle subtended by the arc at the center of the circle will be twice the angle subtended by the arc on the remaining part of the circle. So this CB is subtending A at the other segment of the circle, and same arc CB is subtending at the center 2A, right? We know this formula and we learnt in class in 10th, right? So from here we can say that, yes, let us draw a perpendicular. If you draw a perpendicular from O to BC, right, this perpendicular, we know that the perpendicular drawn from the center of the circle to the chord bisects the chord, right? We are using the previous theorems, okay? So that means from this point, if this is P, right, if this point is P, then PC will be equal to PB, and this R is OC equal to OB, right? I am saying that PC is equal to PB, OC is equal to OB is equal to R, and OP is the perpendicular, right? So from here we can say that by, and even this angle is 90 degrees. So anyway, we can prove the congruency of the triangles. Which triangle? Triangle OPC and OPB, right? Triangle OPC. Hi Karan, good morning. So we can prove the congruency of the triangle OPC and OPB, right? OPB. So from here we can say that, my dear friends, if these two triangles are equal, Then the by CPCT corresponding areas, corresponding angles, corresponding sides will be equal, right? So we can say that yes, if this angle is 2A, then this angle, I mean to say angle POC will be equal to angle POB, and both will be equal. So we can write angle POC is equal to POB, and both of them are equal to 2A. So we can say that POC is nothing but 2A divided by 2, isn't it? If the whole angle is 2A and both of these angles are equal, then this angle will be equal to A, right? So from here we can say that yes, angle POC is nothing but is equal to A. A, that means the same angle which is subtended here. This angle is equal to A, right? Now this PC will be equal to PB. We have seen it, and PC is equal to PB is nothing but a small a. If these both are equal, then definitely the length of this PC will be equal to a by 2, isn't it? As PC is equal to PB, can we write it that PC is a by 2? We have already proved the congruency, my dear friends, right? So now take the sine of this angle A, right? So sine of this angle A, I mean to say in triangle OPC, in triangle OPC, what we can say that sine of angle A will be equal to perpendicular by hypotenuse. So perpendicular will be this one PC, and PC is, let me write over here, PC divided by OC. OC is your radius, and PC is equal to PB, and the entire length PC plus PB is A. So PC and PB are equal, so it is equal to A by 2, not A, right? Because these are equally bisecting. You remember the theorem, perpendicular drawn from the center to any chord of a circle, right? So from this we can write the length of PC. The length of PC is A by 2. So just write A by 2 over here into the numerator, A by 2, and into the denominator OC. What is OC? OC is nothing but capital R. So my dear friends, from here we can write that yes, sine A is equal to A by 2R. From here we can write sine of A is equal to A divided by this 2 going to the denominator, and this will becomes 2R, right? Or we can say that if sine A going over here, then we can say that 2R is equal to A by sine A, right? So in this way we can prove that yes, we have proved the part of the sine rule, that A by sine A is equal to 2R. Similarly, if you draw the perpendicular from O to C and draw the perpendicular from O to B, right, you are able to prove that yes, sine A by sine A, as we have proved A by sine A is equal to 2R. Similarly, it can be proved that, let me write it again, since A by sine A is equal to 2R, we have proved it. Similarly, we can prove B by sine B is equal to 2R, and C by sine C is equal to 2R. This is your formula, my dear friend. This is the sine rule. This is the sine rule. right? Where a small a small b, a small c, a small a small b, a small c are the sides of the triangle, and capital A, capital B, capital C are the angles of that particular triangle, right? So we will see the derivation of this sine rule for the three different triangles. Okay, it can be an acute triangle, it can be an obtuse, it can be a right angle triangle. Okay, so we can go into that also, my dear friends. Okay, so from here, this is the derivation that how a by sine a equal to how b by sine b and how c by sine c, all these are equal to 2r. We have just proved it. Okay, now from here, let us say we have a triangle. Let us say we have a triangle. I am going to the second part of the, if we have an acute angle triangle, okay, then if triangle abc is an acute angle, then definitely all the angles of that triangle is less than 90 degree, right? This is the triangle with us. This is the triangle. So for an acute angle triangle, what will happen? For an acute angle triangle, we'll consider all the three cases that can, that if the triangle can be acute, can be obtuse, can be a 90 degree, right? For an acute angle triangle ABC, let me write it A, B and C, right? And these are the sides opposite to it are, and the sides opposite to it are, opposite to angle A is a small a, opposite to angle B is a small b, opposite to angle C is a small c, as we did earlier, right? So from here, my dear friends, we can say that yes, for an acute angle triangle, we can say that if you draw a perpendicular from A to here, if you draw a perpendicular to from A to BC, right? Then being a 90 degree, let us say this is B, right? So from here, let me shift a little. So from here, we can say that if you consider the sine of A, sine of A is what? Tell me. Sine of A is nothing but, if you consider the angle A, right? If you consider the angle A, this one, right? Then we can write that since we have perpendicular drawn from A to BC, we can consider for B and C over here. But if you are going to calculate for A, you need to draw a perpendicular from C to AB, right? C to AB. So let us consider for B first, because we already drawn a perpendicular from A to BC. So in this case, what will be the value of sine B? Why we have taken this angle now instead of A? Because considering this APB, this triangle, which is a right angle triangle, this triangle, right? We can say that sine of B is nothing but AP by AB. Sine of B is nothing but AP by AB, perpendicular by hypotenuse, and this AB is nothing but C. AB is nothing but C, so we can write it as AP by a small c, right? Because the length of AB is C, right? So from here we can say, so from here we can see that yes, C, this AP can be written as C times sine B. C into sine B is the length of this perpendicular AP, right? C into sine B, right? Similarly, as we have proved this, let me take my pen, highlight it, right? Similarly, we can prove if you draw perpendicular for angle C, right? For angle C, what we can write? This will be equal to B times, because opposite to B is this one, B. This is B, right? So we can write C times was sine B. So B times, this is the length B, side small b, into sine of which angle? C, will be equal to the length of this perpendicular AP, right? So, hi Kailash, hello. So from here we can say that yes, B by sine C is also equal to AP, right? So when you compare all this, okay, when you compare all this, we can write that yes, C times sine B is equal to B times sine C. This will give you, this will give you C by sine C equal to B by sine B. C by sine C is equal to B by sine B. Similarly, we will draw the perpendicular from here and we can prove this is equal to that, and we can prove that this is equal to, this will be equal to A by sine A. So in this way we can also prove that yes, for an acute angle triangle, this is proved, this sine rule is valid, right? So from here, hello Kailash, on time my dear friend, as we discussed yesterday. Yes, we started on time 8 o'clock. Yeah. So in this way, this is the sine rule, and how this will be equal to 2r, we have seen that, okay. But this is the condition for acute angle triangle, right? Now when you consider an obtuse angle, okay, or let me do it for a right angle triangle first, right? For a right angle triangle, it's very easy. You know how? For a right angle triangle, let me change the page, okay, and zoom a little more. Yeah, for a right angle triangle, if this is the triangle in front of you, we have considered for the acute. Now for a right angle triangle, a triangle whose one of the angle is 90 degree, we are considering for it. For a right angle triangle, let us say this is A, this is B, and this is C. This is B and this is C, right? This angle is 90 degree, right? So from here we can say that this angle is 90 degree, right? And the corresponding side opposite to angle B is a small b, side opposite to angle A is a small a, side length of AB opposite to angle C is a small c, right? This is the same which is valid for all, right? Which we are considering for all. This is normal nomenclature. A small a small b, a small c represents side, capital A, capital B, capital C represents the angle of that particular triangle, right? If you consider the right angle triangle, this right angle triangle, right? Then we can say that yes, sine of this angle, sine of one of the angle which is 90 degree is equal to sine of pi by 2 or 90, which value is equal to 1. This will be equal to 1, right? And if you consider sine of this angle A, triangles class 10 important questions please. Okay Kailash. Okay, but don't ask me to do it today. Let us keep it for tomorrow. Okay, for sure. This will for 10 important questions tomorrow morning. Okay, let's be ready. Okay, I will come between 6 to 8. Is it okay? So sine of A, but you should not stop till then. You should keep on your preparations. Okay. But yes, 10 important questions. I will take it up tomorrow. Okay. Thank you. So if you consider A, sine of A, we know sine of A, that means perpendicular over here will be a small a divided by hypotenuse. This is equal to C. Hypotenuse is equal to C. Similarly, when you consider sine of B, right, this one, then perpendicular will be a small b. So this will be equal to a small b divided by hypotenuse, that will be a small c, right? So from here we get sine A as A by C. From here we get sine B as B by C, right? So just replace the value of C from both of these, right? If you replace the value of C from here, we can write that yes, C is small c is equal to A by sine A, right? And from here we can write a small c as B by sine B. So similarly, if another angle will be 90, we can prove. So it's easy, and we can prove that yes, for a right angle triangle also, as we have proved A by sine A equal to B by sine B, same can be proved as equal to C by sine C, right? So for a right angle triangle also, we can see that yes, the sine rule is equally valid, okay? And this can be proved, right? This can be proved. Now, the third option which is left with us, we will see the derivation today, my dear friends, okay? And if you just we consider the right angle triangle, okay, we have already considered the normal acute triangle, and after that let us consider an obtuse triangle. If an obtuse triangle is there, that means one of the angle is definitely greater than 90 degree. Let us say this angle is greater than 90 degree, right? And it can be A, B, C, this triangle, and similarly as we seen, the length of BC is a small a, and here it's a small b, and here it's a small c, right? So this is the case for the third one, the obtuse angle. How the sine rule is coming for an obtuse angle triangle, right? So for an obtuse angle triangle, we can say that yes, as we have proved earlier, what is the value of sine c? Sine c, in a, for the sine c, if you are going to apply the sine c, then definitely there should be a right angle triangle. So just draw a perpendicular from here and make this triangle ABC, not ABC, a new triangle, let us say APC, as a right angle triangle, okay? Just extend BC to P and drop a perpendicular from A to the line BC, right? So we can say that if this angle is 90 degree, right, then we can say that yes, this sine of C will be equal to AP, will be equal to perpendicular, that is AP by PC. Sine of C is equal to AP by PC. Any doubt into it? I don't think, right? AP by PC, right? So from here, AP by PC is calculated as a value of sine C. So what will be the value of this AP? AP can be written as PC times sine C. This is PC, right? Times sine C, right? And this PC times sine C. Is it okay? And what is the value of this PC? PC will be PC will be PC will be BC, this A, PC will be this BC plus this PB. isn't it? This will be equal to PC into sine C is the length of this perpendicular AB, right? Is the length of this perpendicular AB, AP. Okay. So, and the length of PC here can be written as length of PC into sine C is equal to AP, right? Similarly, we can show that this length of perpendicular, okay. So my dear friends, we can easily say that yes, the length of perpendicular AP, this one, can be written as PC. PC is nothing but A plus PB, right? We can substitute for PC over here. PC, right? You can keep it as it is and let us move forward. Okay? When you just move forward, you can see the angle AB, this one, this angle. If you consider this angle, angle ABP, for angle ABP, we will come to this, okay? We just park it, okay? If you consider angle ABP, right? For angle ABP, we can write that if this is angle B, right? Then this angle will be nothing but 180 minus B. 180 minus B, right? If this is 180 minus B, then if you consider sine of 180 minus B, this one, right? What we have considered, then in triangle APB, in triangle APB, right? In triangle APB, I mean to say this triangle. We are considering the case of an obtuse angle triangle, my dear friends. Okay. Then here we can say that sine of this angle ABP, sine of angle ABP is equal to this AP by AB, AP by AB, and AB is nothing but this small c, and ABP is nothing but 180 minus B. So just put it over here, this 180 minus B, this one. Sine of 180 minus B is equal to AP by AB, and AB is nothing but a small c, right? So from here, my dear friends, we can see sine of 180 minus theta. If you consider the quadrants here, all positive, sine positive, cos, all sine, tan, cos. So tan and cos. So leave it. You can see 180 minus B is the angle which is lying somewhere into the second quadrant, and here sine is positive, right? So this will give you sine of B, right? This will give you sine of B is equal to AP by C. So this can be written as C times sine B. C times sine B as the length of AP, right? C times sine B as the length of AP here, right? C times sine B. Similarly, this AP can be proved as B times sine C. right? This can also be proved. So when you just equate both of them, again we get c times sine b is equal to b times sine c. So this will give you c by sine c is equal to b by sine b, and similarly it can be proved as equal to a by b by sine, sorry, here it's b and a by sine a. So again, for an obtuse angle triangle also we have proved that yes, c by sine a by sine a equal to b by sine b equal to c by sine c. The sine rule is equally valid. Okay. So my dear friends, we have seen that yes, this is the derivation of the sine rule for acute, obtuse and right angle triangle which we have seen. And what is sine rule? We will see the applications into the next class, but not tomorrow. Tomorrow we'll be taking it for a triangles. We'll take 10 important questions from triangle chapter class 10 as asked by Kailas. Okay, requested many times. So okay, let us take it up. Tomorrow I will take up 10 good questions from triangle chapter from class 10 on the same time between 6 to 8. Okay, so it can be little plus or minus, so I think just bear with me, my dear friends. Thank you so much for watching. Take care. Bye bye. See you into the next class. See you.